Now, sometimes using a box of whisker plots is not going to be your best of choices, especially because sometimes you have way too much data. Now, another thing we can use is called a z-test, and we've got this formula here, which seems like just a bunch of mumbo jumbo at first, but let's go through it piece by piece. So you've got z equals x bar minus mu over sigma over the square root of n. That's a lot of stuff there. So let's break it down piece by piece. This x bar, we looked at that last week. That is our calculated mean or average. So using the actual real data, that's what we get. Now this mu, I'm going to call it the expected mean, or maybe even something that we're going to see quite often in this section. Sometimes it'll be called a claim. What some company or some individual is claiming is the mean of all your data. This sigma down here, that's our standard deviation that we learned about last week. And this n value here is our sample size, however many values we have. So our number of values. Now, a little more information about our z-score. Two things here. If our z-score is greater than 1.96, then we can reject the null hypothesis with 95% certainty, which means we're rejecting that there's no difference. In other words, we believe that there is a significant difference. Secondly, if our z-score is less than, the absolute value of the z-score is less than 1.96, then we don't have enough evidence to determine or to reject the null hypothesis. You'll notice it doesn't say we accept the hypothesis, we just don't have enough evidence to reject the null hypothesis.